So here we have another multi-angle equation, multi-angle trig equation, and I'm asked to solve for omega over the interval 0 to 2 pi. And remember, when it says 0 to 2 pi, it's talking about omega, not 2 omega, like we have here. So when you're dealing with this one, you have to remember that omega is going between 0 and 2 pi, but 2 omega goes over a larger interval, 0 to 4 pi, which means we're going to have more solutions from our unit circle than normal. We're going to be dealing with coterminal angles. So the first thing you do is, as always, isolate the trig function. Okay, and here's what I mean by that. We've got 2 times the sine of this big complicated thing. Don't worry about that yet. Okay, we'll get to that later. Plus radical 3 equals 0. So I've got this equation, and by isolating the trig function, I mean I want sine by itself. So that means we're going to subtract radical 3 from each side. We're going to divide each side by 2, and I'm going to get something that looks like this. Sine of big messy ugly thing equals negative radical 3 over 2. Okay, so where is that on the unit circle? Well, let me give myself a little space here. And let's put a unit circle right there. Okay, so there's my unit circle. Negative radical 3 over 2. Well, that's a y value, right? It's a y coordinate value because this is a sine that we're talking about. And it's kind of one of the big ones. 1/2 is a small one. This is a big one. It's fairly steep. It goes almost down to the bottom of the unit circle. It's so negative. So what are those angles right there? Well, this looks like 4 pi over 3 on the left and 5 pi over 3 in quadrant 4. So those are my two angles, meaning 2 omega minus pi over 6 equals 4 pi over 3 and 5 pi over 3. Except we're not done yet, right? How many times around the unit circle am I going? Remember what we just talked about at the beginning. I'm going twice around the unit circle. So that's just once. I need to go again. So what are some more angles in here? Well, add 2 pi to each of these angles. You'll come up with, let's see, 2 pi is 6 pi over 3. So that's, okay, then we come up with 10 pi over 3 and 11 pi over 3 as coterminal angles. Now, to each of these coterminal angles, we need to solve this equation, okay, which means 2 omega equals, now we add pi over 6 to each of those 4 angles. Well, it helps if you can convert these to divided by 6 in your head. In fact, let me just walk through that step by step here. I'm going to say I would rather talk about these things as sixths, okay, instead of thirds, because that will be a common denominator, and it'll make it easier for me to do some of the math in here. 2 pi over 6. Great. So now I've got everything with the denominator of 6. I'm going to add pi over 6 to each side. So now we get 2 omega equals 9 pi over 6, 11 pi over 6, 21 pi over 6, and 23 pi over 6. And now we divide each side by 2 to get, drum roll, just omega. It's going to be 9 pi over 12. Well, this part's easy. 11 pi over 12, 21 pi over 12, and 23 pi over 12. There's our answer. If you want to simplify some of these things, that's really just fine. It's not necessary, right? You could, if you want, for example, write 9 pi over 12 as just 3 pi over 4. But either way, it's getting marked correct. Okay, the important thing is you're going around the circle twice because it's a 2 omega equation, and you know what to do with this little pi over 6 horizontal shift in there. All right?